Hello everyone, I promised you all last time that in this next video here I would get you started on actually assembling a computer. I don't know exactly how far we'll make it today. Like I noted at the end of the last video, this is a relatively standard experience that we have here. There's nothing real complex. You can go pretty wild with liquid cooling computers and things like that, and I often do on the computers I build for myself because it's great fun. But I figured that as an introductory video, just a normal computer that you're likely to have like sitting on your desk, and you could follow along because the parts will look vaguely similar if you so desire, would probably be the most beneficial. So let's get into it.
I do assembly. Usually, I do most of the assembly outside of the case when I can, because honestly, it's a pain in the ass to do it in the case. Oh, one other thing before I get started. On the motherboard, like most things will connect to the motherboard, which you'll see here, but the motherboard is attached to the case via screw holes that, this. There's another one here, here, there, and there's another one. And you can generally just find them. You don't have to worry about screwing stuff up. Like, I have a pretty small screwdriver, but you don't need a really little one because they are electrically isolated from anything important on the motherboard. So you don't have to worry about
One thing to note about that electrical isolation is some extremely cheap motherboards don't do an especially great job of that. I mean, they will be electrically isolated from the factory, but you can see here, for example, there's these like metal rings in here, and the same for this one, and this one, and this one, and that is some evidence that not only is the are those screw holes electrically isolated from important things on the board, and you can see some of those important things here, like they're usually called traces, where you run tiny, tiny, tiny copper lines through, well, not necessarily copper, metal of some sort, lines through the motherboard to carry your signal. Well, you don't want this over that, right? So when they're isolated, you can also reinforce them, meaning that no matter how many times you take a screw out or put a screw into this hole, you're never going to wear through the plastic around it, called the PCB a lot of times. You're never going to wear through that material and start getting closer to this, right? To these wires that matter, and they're or these wires that matter, right? So that is some evidence that the screw holes are reinforced. And the reason that is important is you can get some unpredictable and unfortunate behavior depending on the situation if those are not enforced or reinforced. Now, on this motherboard, just at a glance, it doesn't look like we would have any issues anytime soon, even if it wasn't enforced. But on some extremely cheap situations, you can get unlucky. So it's not something to watch really when you're buying. It's more something to just be aware of over time. Depending on how far into computers you get, it could be more relevant. On a motherboard, you're usually fine.
connecting some metal and shocking.
I also forgot the screw hole pattern is part of a standard called ATX. And the ATX standard has been around for a very long time, and you can go absolutely crazy trying to read about it on your own. But there's a bunch of different shapes and sizes of motherboards that are acceptable with different screw positions and so on.
A component or anything on the board and breaking it. And while I'm thinking about it, all of these parts are on an anti-static mat. You don't need that. I've assembled computers on the carpet. I'm just doing this because it actually made it easier to see parts, believe it.
I don't really recommend assembling computers on carpet because that's a good way to build up static electricity. However, if you do, like I say in the video, I've done it a bunch of times and never had anything go wrong. So that's really your choice how to assemble it. Modern computer parts have gotten very good at protecting themselves from electric shocks because if you have people putting computers together and buying your parts and they don't do a good job of that, you'll get a bunch of parts getting mailed back to you and a ton of user complaints, and it's very expensive. So companies have tried to mitigate a lot of that.
Or not. Um, just don't do anything completely idiotic, like rub your feet around on the carpet and then go zapping components. However, I have literally done that and I've never managed to break anything. I just promise nothing if you decide that's what you want to do. And once it's all assembled, it'll be grounded through the power supply and its housing. So the case will ground through the back here where the power supply kind of mounts. The case will ground to the power supply and then through the power supply into an outlet.
I don't know if that's completely and 100% correct anymore. It's been too long since I've had to care, frankly. Um, but then even if it's not correct in detail, the general idea is definitely correct, and the general concept is the power supply is responsible for grounding everything. So it's important to, or the vast majority of things. So it's important to make sure that everything is connected to your power supply correctly, and your case is it's connected to your case correctly, and things like that. There have been fairly well known YouTube channels who posted computer building guides who got that information very wrong. So if you have any concerns about how things are grounded in your system, please do a little bit of research. Be warned, it's not really a topic for the faint of heart. It's probably beyond somebody looking at this video as kind of a beginner's guide. But if you're curious and want to satisfy that curiosity, there's a ton of good info out there.
Everything else is going to be electrically isolated from the case. So the only way it has to escape is the power supply, or I guess the feet on the case, or any other metal touching the case, or any other conductive material touching the case. But the important part is it can't possibly get to your components. So let's start. I always start with the CPU, and in your case, you have one with a bajillion tiny little pins on it. And this is not as common to see anymore. But the important part is if you bend one of those, pretty good chance that your CPU won't work anymore. It's worth trying, right? Because some of the pins are unused, but there's a pretty good chance it won't work anymore. So if you look kind of from the top down here, you can obviously see the logos, but you see in the bottom right corner there's a little gold triangle, and then if I flip it over, under there, the camera's not going to want to focus on it, but you can see in that same corner, now the top left, there's some extra gold plate, and it's just a plate, right? It's not pins. That should match up with an indicator right here on the motherboard. So you can see the top left of that picture, there appears to be a little indent in the plastic housing in this gray thing here, in the socket, it's called. That should align with something on the processor. And you can get a little extra hint of that by seeing that this corner is square and the other corners are kind of at an angle with where pins are. And then if I look back at this, you'll see that that is also a square shape up in the corner where there are little holes for pins, and the others are not. And then you also have the little extra divots that you can see there, or points that you can see there, kind of scattered in the middle of the pins, lining up with gaps in pins. So The name of the game is to just sort of gently set it in there. You shouldn't have to force it or anything. And then you should theoretically unlatch it first. So I'm just going to make sure that it's seated correctly and it looks fine.
It is worth noting that this process will vary a lot from one computer to the next, particularly depending on the manufacturer of the processor. Um, so, for example, on an Intel system, you remember on this AMD system, on the AMD processor, there were a lot of little pins, right? Well, on an Intel computer, those little pins are actually going to be on the motherboard, and the CPU will have, or the processor, will have kind of flat pads that are metal for those pins on the motherboard to connect to. So in a way, it's kind of the reverse of this motherboard and CPU combination. And that has various advantages and disadvantages, which don't matter at all in this video. But the thing to keep in mind is that that means that on this, right, your CPU is most likely to have a damaged part rather than the motherboard, because the pins are on the CPU and it's easiest to bend those pins by accident. Of basically everything when you're building a computer, that's one of the most failure intensive steps, is accidentally bending one of those when you're taking it out of the packaging, or maybe it got shipped to you bent and then you have to try to send it back, right? But this is kind of nice because well, yeah, I'll say nice because there's no socket cover or anything, because the motherboard is very unlikely to be damaged because it's protected from everything. However, on an Intel system where the pins are on the motherboard, now the motherboard has to be protected. The motherboard socket has to have a plastic cover over it because it has the fragile pins. So, on an Intel system, you'll see a little plastic cover where I dropped this CPU here. It'll be roughly the same size. There'll be a plastic cover with a metal kind of shield looking thing around the cover, and a similar metal bar used to open up the shield, right? So when you lift that, it relaxes the shield and plastic cover, and then you'll put the CPU in the socket. There will be a similar indicator to how I was talking about this. However, the motherboard manufacturer often clarifies in the manual or quick start guide. So, once you get that open, the shield off, right, or loosened so that you can put the CPU in, things start to look pretty similar then. However, as you relatch the cover, that shield and plastic cover I mentioned, onto the CPU to press it down firmly, here I'm about to close this lever and it's just going to lock. It's basically going to grab those pins. The motherboard will grab the processor's pins and lock it in place. On an Intel system, at least again at time of filming here, it's a little bit different. That shield is what actually keeps the processor from sliding around on the motherboard. So as you lower the arm on an Intel system, this arm, that will tighten again, and as that tightens, the plastic cover will pop off because you don't need it anymore. And you don't want to remove that plastic cover early because you want to make sure absolutely nothing gets into and wrecks that CPU socket with the pins in it, right? The motherboard with the pins in it. And make sure to keep that plastic cover, because if you ever have to send the motherboard back in, then sometimes you'll have to include that plastic cover, or they'll just send it back to you, saying that they won't refund you or whatever because clearly you lost an important piece.
Then you latch it back down with that little lever. So the CPU now is attached.
This video is already getting a little bit long, so I think I'm going to stop it here. This is what we witnessed was one of the most complex parts of building a computer, as well as one of the most failure-prone parts. Just dealing with the CPU and getting it into the motherboard. Once it's there, there's very little reason that you'll ever have to mess with it again. Besides, well, you'll see in the next video or an upcoming video of one place that you may have to deal with the CPU again. But I will save that for the next time. I will see you all in the next one.